faint point of light follows the sun down behind the hills. It's Mercury, one of the most elusive sights in the sky. Some astronomers live their whole lives without seeing it. Traveling in from space towards the sun, past the 9 planets that make up our solar system, you'd come to Mercury last of all. Past Mars, Earth, and Venus, it's a tiny, sun-scorched, mysterious world.
The trouble with Mercury is that it's so small and elusive that until recently, practically everything we knew about it was wrong. For instance, when I was a kid getting into astronomy, I used to pick up a book like this, and I'd read something like this.
His day is as long as his year. Now that will make him a very curious world indeed, for it means that he must always turn the same side to the sun. It is very strange to think of this little world with one of its sides forever bound in ice and darkness, and the other forever at the boiling point.
He's involved in a dense atmosphere which obscures his actual surface markings and shelters his landscape from the intense heat of the sun.
Not one of those statements is true. The problem for astronomers is that Mercury is almost impossible to see against the sun's glare. What we do know is that to stop being pulled into the sun by gravity, Mercury has to circle it faster than any other planet. Even the Romans knew that Mercury was the quickest thing in the sky. And that's why they named the planet after the fleet-footed messenger of the gods. 2,000 years later, we didn't know much more. Even giant telescopes like these could only show us Mercury as an indistinct fuzzy blob. Astronomers couldn't even see if it was spinning like other planets. The answer to that came in 1965 from a radio telescope deep in the heart of the Puerto Rican jungle. The Arecibo dish is the world's biggest radio telescope. Scientists here can transmit radar waves from its giant dish to measure the rotation of the planet. If the planet's turning, it affects the radar waves as they bounce off its surface back to Earth, millions of miles away. If they hit part of the surface that's going away, they're stretched. If they hit part of the surface coming towards them, they're shortened. Back at Arecibo, they analyzed the radar echoes. The results from Mercury showed that astronomers were wrong. It does spin, very slowly. So the sun does set on Mercury, but in a most peculiar way. If you were there, you might see it sink slowly in the west. But then, as Mercury accelerates around part of its egg-shaped orbit, the sun actually starts to rise again. Finally, as Mercury comes out of the bend, the sun is able to set properly. And it's night on Mercury for the next 88 Earth days. In November 1973, America's Mariner 10 took off for Mercury, the only spacecraft that's gone there. Skimming past Venus en route, it was pulled towards Mercury by the sun's gravity. It arrived at Mercury in 1974, having completed the 100 million-mile journey in just 5 months. Mariner 10 is still in orbit around the sun today. Hal Mazursky, astrogeologist, was in at the launch.
Yes, Mariner 10 flew by Venus and then on to Mercury. And a very clever Italian dynamicist by the name of Colombo figured out if we flew by the sun, you could bend the trajectory and fly by again. And we flew by Mercury 3 times taking pictures.
On each of its 3 sweeps across the planet's surface, Mariner's cameras took hundreds of overlapping photographs. They were crystal clear because there was no atmosphere. Segment by segment, a new world was being recorded. Each picture was turned into electronic signals which the probe transmitted. This giant receiving dish in Goldstone, California, picks up the faint whispers from space probes. It's just one of the dishes around the world that make up the deep space network. A microwave link relays the messages from space to JPL, the Jet Propulsion Laboratory in Pasadena. This is the nerve center of planetary research.
In a way, it's a bit like a cosmic telephone exchange. The signals are processed here and are sent out to its subscribers, the planetary scientists, and they, in their turn, can use JPL to call up their probes and check up on how they're getting on out there in space.
Information from the probes is fed to the U.S. Geological Survey in Arizona. Here, planetary geologists study the surfaces of other worlds. But first, they need a map. A huge number-crunching computer turns the signals back into pictures and prints out a reference grid to show where they fit. And with some human help, a complete picture of another planet starts to emerge.
It's rather like Christmas during a mission. You're unwrapping a world for the first time. You're dealing with seeing an alien surface that no one's seen before. Right now I'm putting a mantle or a flow pattern around a crater here. It looks as if it's...
Jay Inge has the job of smoothing out and improving the computer's jigsaw. What he makes are the most meticulous artist's impressions in the world.
Of the crater. Bring it up a bit more. But the point to remember is we're making a photo interpretation. We're not making a photograph. The interpretation I make will be looked at by other scientists. It will be corrected for errors. It will go out and other people will throw darts at it and make other little comments of usually a friendly nature. Sometimes the comments aren't too friendly, but we have a very good working relationship with the scientists, and we attempt to do what we can to make the product look as best representative of the surface as we can. Let's bring our little crack in here that appears in the photographs. The rill breaking through here right now seems to indicate that nature can do more than make round circles called craters, and that's important to us, at least to my sanity. We get tired of drawing nothing but craters all day. The fun of it, though, I can't begin to communicate that. I never dreamt I would do this. I never dreamed that I would have a chance to actually be working on making maps of other worlds when I was a mere teenager, looking at them through a telescope. That's good fun. So, onward with the rill and the crack. It does get boring at times, believe me.
This is the end result, a globe of Mercury covered in craters. Thanks to Mariner 10 and a lot of hard work, all is revealed. Mercury turns out to look very much like the Moon. Is there any way one can spot the difference?
Yes, to a real expert, he can look at the craters in one picture and tell the lunar craters from the Mercury craters. Mercury is almost twice as dense as the Moon, so the material that's thrown out doesn't fly nearly as far. And a real expert can recognize this just like he would his own children.
The craters on Mercury were produced by bombardment when it was young. At that time, the solar system was a dangerous place. Asteroids left over from the birth of the planets were whizzing everywhere. Where they hit, colossal scars were left on the planet's still molten surface. Today, every part of Mercury's surface is covered in craters. The huge old scars have been peppered with smaller craters caused by later impacts. But it wasn't just Mercury that suffered space bombardment. There are craters on all the planets.
And here, at Meteor Crater, Arizona, is an enormous hole nearly a mile across, punched into the ground by a huge meteorite which fell about 50,000 years ago. Most of the craters on the Earth have been obliterated by wind or by rain, but on airless Mercury, the craters last forever.
There's more to Mercury than craters alone. Crossing the surface, regardless of terrain, are long, curved scarps, something quite unique in the solar system.
Well, there are fractures where the crust has been broken and ridden over each other. It's the only planet that we've seen where this process seems to be taking place. We think it had to do with so-called core formation. When the dense material melted and fell into the center, and we think the outer crust shrank a little.
It seems the shrinking surface produced the scarps, which can still be seen in Mariner's photographs. Those old textbooks had it all wrong. Mercury isn't half-baked, half-frozen, and it hasn't got a protective atmosphere. It's just a dead, hot, airless little world whose wrinkles are already showing. Far more glamorous is the next planet out from the sun. Shining brightest of all the stars and planets is Venus. She's been an inspiration to romance down the ages. Our fair-haired angel of the evening, now, whilst the sun rests on the mountains, light thy bright torch of love.
Good evening.
Hello. Venus is a planet of romance. Back in the mists of time, people named it after the goddess of love because Venus is quite literally dazzling. No other planet shines as brilliantly. And that's because Venus, true to form I suppose, hides itself under a thick mantle of highly reflective clouds. But Venus is also the closest planet to the Earth, and the combination makes Venus into a world of tantalizing mystery.
Through a telescope, Venus looks like a misty moon. Even under the penetrating scrutiny of a space probe, Venus remains modestly veiled beneath her covering of clouds. Four centuries ago, Galileo became the first person to study Venus with a telescope. He lived in Florence, and I visited the church where he's buried with historian Carol Stott. Galileo spent many years studying Venus, but with his primitive instrument, he just couldn't penetrate the all-enveloping clouds.
Yes, yeah. And after Galileo, other astronomers tried to develop the telescope to actually look at Venus and see if they could really find out the structure of the planet, the surface of it. But it was to no avail, and they really had to just resort to speculation. And the most far-fetched idea was from a German aristocrat who actually thought the planet was inhabited, and underneath the cloud coverage were the inhabitants who were actually having bonfires, and those bonfires are what we can occasionally see as light patches on Venus from the Earth. One other idea was that it was like an early model of the Earth, so that it would be still warm, it would be wet and dripping, and have forest and vegetation, very luxuriant. But if you take that a stage further, other people actually thought that it was completely covered in water, and so it'd be one big ocean.
Altogether, it was thought to be a very pleasant place, perhaps a twin sister to the Earth. After all, they are very nearly the same size. And being slightly closer to the Sun, Venus might be pleasantly warmer, a veritable paradise. And so, it was with hopeful anticipation that the Russians launched the first ever Venus probe, Venera 1, in 1961. Built like a diving bell, Venera was targeted towards Venus's dense atmosphere. In the event, it missed the planet altogether. The Russians shot probe after probe towards Venus, but they all went the same way. As they disappeared under Venus's mantle of cloud, their transmissions mysteriously stopped. It was back to the drawing board. The Russians began to suspect that Venus was rather inhospitable, and they started to build probes that could land on the surface and withstand anything the planet could throw at them. Pressures of 100 atmospheres, temperatures of 600 degrees Celsius. Nothing was left to chance. Even the cameras were made to be virtually indestructible. The color balance was tested in a film studio on a set designer's idea of the planet's surface. These latest Veneras would drill into the surface to take rock samples. They could analyze them by remote control in a mini laboratory on board, bombarding the samples with radiation to reveal their composition. Finally, in Russia's equivalent of mission control, everyone waited for news as the spacecraft descended through Venus's thick atmosphere.
Data have begun coming in. They're of good quality. New information has been received. The presence of neon has been registered in the Venusian atmosphere. No thunder dischargers so far, but the instrument called Groza is working. Attention. According to the telemetry, the Venera 13 lander has touched down on the surface of Venus.
The years of testing paid off. Venera's armor-plated cameras sent back clear color pictures for an hour before succumbing to the harsh conditions it revealed. A sister craft landed 600 miles away and photographed an equally desolate scene, a flat expanse of rock glowing with heat. The real Venus is less like paradise, more like hell. Even a volcanic landscape on Earth bears little comparison to the surface of Venus. The Veneras have shown that it's searingly hot, with a dense atmosphere of choking carbon dioxide and sulfuric acid rain dripping from the clouds. A spacefarer setting foot on the planet would be simultaneously roasted, squashed, corroded, and suffocated.
There's no doubt that Venus is the most hostile and unfriendly planet in the whole solar system, quite unlike our luxuriant Earth here. But how come the two planets developed so differently?
On Earth, the sun's heat passes through the atmosphere and warms the surface of our planet. Most of the heat is radiated back into space, so we stay at an even temperature. Long ago, Venus was probably cool enough to have seas, but its atmosphere contained more carbon dioxide, which trapped most of the heat like the panes of glass in a greenhouse. And so, as time went by, Venus's temperature rose and its seas eventually boiled away. Today, Venus is a red-hot world. These swirling clouds cover the hottest world in the whole solar system. And now, at last, American scientists have found a way of seeing through these clouds. Hal Mazursky proudly presents a new view of the planet.
We have essentially a global map of Venus, or 93% of it. That was done by the Pioneer Venus spacecraft that went into orbit in December of 1978 and is still alive and well.
So how did you manage to see through the clouds?
We used radar. That's really a radar altimeter. You fire a burst of energy at the surface and it bounces back and you measure the time. And that tells you the elevation of the surface.
Under radar scrutiny, Venus is naked, her contours visible for all to see. From the hundreds of radar soundings it made, Pioneer Venus was able to build up a global map of its mountains, valleys, and plains. Here, the highlands and lowlands are color-coded. Highlands are green and yellow, while lowlands are picked out in blue. Most of Venus is covered with a huge planet-wide plain. Only the polar caps were left unprobed by Pioneer's radar. Our maps of Venus are growing more detailed. The new features, like the old, are named after famous women. An honorable exception is James Clerk Maxwell, a physicist whose name has been given to an enormous mountain.
Venus is very effective at making mountains and highlands. The highest mountain on Venus is Maxwell Montes, and it's 1,000 meters, 3,000 feet higher than Mount Everest. And it's sitting next to this high plateau, which is 1,000 meters higher and twice as big as the Tibetan Plateau, the biggest one on Earth. And there are lowlands that are about a third as abundant as the lowlands on the Earth, and they're only 1/5 as deep. The processes that make highlands on Venus are more effective than those on the Earth, and the ones that make lowlands are less effective. When we first saw the global configuration of Venus, we looked for the features that are characteristic of the moving plates on the Earth's surface. The most characteristic thing on the Earth is that we have great ridges that run down the centers of the great ocean basins. We don't see those on Venus. Another thing, there are great lines of volcanoes along the edges of the continents. Those are not there. A final thing, there are deep trenches along the coast of North America and South America, and those are not there. So the most characteristic features of plate tectonic motions we don't see on Venus. See, the Earth gets rid of its heat by seafloor spreading and plate tectonics. That's the great grand synthesizing idea and tells us how the Earth was made. But Venus has to do things differently. It has great fractures, some of which go a third of the way around the planet, and lines of volcanoes along these great fractures. And we think it gets rid of most of its heat by conduction into the atmosphere.
But are the volcanoes on Venus still active? Radio telescopes on Earth suggest that they are. A radio picture of Venus is mottled with hot spots, possibly volcanic eruptions. If there are active volcanoes on Venus, they're making a bad planet even worse. The carbon dioxide belching out into the atmosphere will be adding to the greenhouse effect and trapping more of the sun's heat. Venus might have been another Earth, but it went wrong. Just being that bit nearer the sun, losing its seas and having a slightly different atmosphere made all the difference between heaven and hell.
But in a way, we can learn from Venus's fate, because at the moment we're starting to burn the fossil fuels that were laid down millions of years ago, the dead remains of trees. And as a result, the carbon dioxide amounts in our atmosphere are increasing. And there are indications that over the next century, the Earth's temperature could rise by a whole 5 or even 10 degrees. And with it, the trees would go, and we might end up like Venus. So the message is we need to be careful with our own planet, otherwise we too might end up like that beautiful evening star in the sky.
And if there's life on this planet, what are the chances of finding life on another one beyond the solar system? Next week at the same time, 6 o'clock. There's a Channel 4 paperback called The Planets by Heather Cooper with Nigel Hembest, and you'll find it in the shops, price £6.95.
Boy.